Picture a car with glowing lights dancing across its body, a pickup truck that you can quickly change to a family SUV, or even a family-friendly mobile living room that takes you to your destination while you relax like you would at home. It sounds far-fetched, but these are real designs emerging today. In China especially, new electric automakers are unleashing vehicles that defy everything we thought a car should look like. From futuristic luxury sedans that resemble spaceships to cute microcars decorated in cartoon themes, the world's largest auto market is brimming with creativity. This wave of unconventional, surprising, even bizarre designs has many asking, is this the end of car design as we know it? Or rather, the beginning of something entirely new? These different aesthetics aren't just for show. They're signs of deeper changes under the skin. A revolution in car engineering is underway, one that frees designers from old constraints. Electric vehicle technology is enabling this new era. From flat skateboard chassis to software-defined interiors, it is opening possibilities that were unimaginable in the days of gas engines. The EV's skateboard chassis is central, but what is it? The skateboard chassis is a flat, self-contained platform, where the entire floor of the car is a big, flat battery pack, and the wheels have electric motors attached directly at the front and rear. All the crucial parts, the battery, motors, suspension, and electronics, sit in this slim base, like the deck of a skateboard. What's left above is basically a blank canvas. Designers call the vehicle body a top hat that sits on the skateboard. Because the skateboard contains all the driving hardware, you can put almost any style of body on top without redesigning the fundamentals. This modular approach means a company could use one common platform to build an SUV, a sedan, a pickup truck, whatever shapes they dream up, just by changing the body and tweaking software. It's similar to how computer makers use the same internal components, but change the outer case. For car designers, the skateboard chassis is a game changer. With a flat floor and no big engine block intruding, they are free to play with proportions and layouts that would have been impossible before. Wheels can be pushed out to the corners of the vehicle, shortening the overhangs and creating more interior space. The passenger compartment can stretch out, giving occupants unexpected roominess. Even small EVs can feel spacious inside. If you've ever sat in the back of a traditional car and had to straddle the tall hump in the floor that houses the drive shaft or exhaust tunnel, you'll appreciate that an EV's flat floor eliminates that, making a clean, open cabin design. The skateboard also lowers the center of gravity by putting the heaviest component, the battery, at the bottom. This can improve handling and stability, meaning engineers can tune the car for better ride comfort and performance without worrying about a top-heavy engine up front. And since the motors are compact and tucked away near the axles, there's no need for a bulky transmission running through the car. In practical terms, that frees up space for features like extra storage. Many electric cars even have a front trunk where an engine would normally be. Safety can improve too. With no engine up front, designers have more freedom to create crumple zones that absorb crash energy effectively. All of these technical advantages feed directly into new design freedom. The technology invites creativity rather than limiting it. Even the skateboard chassis is seeing constant development. CATL recently announced their Bedrock chassis that has integrated battery cells directly into the chassis itself. This means either more battery cells can be fitted into the same amount of space, or the chassis can be made lower profile with the same power. Companies like Tesla and BYD have managed this too, with their latest designs bonding the cells directly into the vehicle's body structure, removing redundant supports, and thus saving weight and space. A lighter car can go faster and further, improving performance, but it also has aesthetic ripple effects. Weight savings might allow a slimmer roof or less bulky pillars, while still passing crash tests, potentially enabling more glass or more graceful proportions. Structural battery tech also means fewer constraints on where structural beams must go, possibly enabling features like larger door openings or panoramic roofs without heavy reinforcement. CATL's entrance into this market is particularly interesting, however, as they just make batteries for cars rather than cars themselves. Having advanced ready-to-go chassis from a third-party manufacturer could change the development focus for car brands, and even encourage many new companies to get into the market. This would allow brands to focus
This would allow brands to focus on the things like technology, interior space, and entertainment above the traditional driving-first focus of the past. To appreciate how dramatic this change is, let's contrast it with the old rules of car design from the internal combustion engine era. In a gasoline or diesel car, the entire vehicle's shape and structure were constrained by a myriad of bulky components. You had a heavy engine up front, or sometimes in back or middle, but always taking significant space. A transmission gearbox, drive shafts or axles connecting to wheels, a fuel tank, often under the rear seat or in the trunk area, and exhaust pipes snaking their way to the back of the car. These pieces force certain layouts. For instance, most cars needed a long hood to accommodate the engine and cooling system. That's why traditional sports cars have that classic long nose profile. It wasn't just style, it was necessity to fit a big V8 or V12 engine. Likewise, sedans often had a driveshaft tunnel running down the middle of the floor to send power to the rear wheels, creating that hump that passengers had to work around. The fuel tank had to be placed where it wouldn't be easily punctured in a crash, often limiting cargo or backseat space. And every internal combustion car needed a grille or intake openings on the front to gulp in air and cool the radiator. A key reason front ends all had a similar look, with large grilles acting as a face of the car. All these requirements were like a rigid framework defining what a car could look like. Designers certainly achieved beautiful and diverse styles over the past century, but they were always balancing art and engineering. Electric platforms unshackle designers from the tyranny of the internal combustion layout. They can experiment with proportions, short hoods or virtually no hood at all, longer wheelbases that stretch the cabin, lower or higher roof lines with fewer mechanical obstacles. The aesthetic focus can shift from accommodating hardware to enhancing user experience and brand identity. In the EV era, the emphasis moves to bold design and a strong identity through shape and details. Because traditional engines, and the character they imparted, are no longer a differentiator. Anyone keeping a close eye on the technology space would have probably heard the rumors about companies like Apple, Dyson, and Sony developing electric vehicles. While a lot of these projects appear to have been cancelled, some look to be making it to market, like the Sony and Honda collaboration, the Afeela One, which had its pre-orders announced at CES 2025. This seems to make sense, as Sony is a massive manufacturer of sensors, cameras, and screens, among other technologies being utilized by many other brands and products around the world. Their partnership with Honda appears to allow Sony to focus on the modern electronic aspects while leaving the traditional car-building aspects to Honda. This makes technology companies uniquely well positioned to take on the car market as they shift away from mechanical to electronic engineering, with software becoming a far more prominent differentiator. In this new landscape, terms like software-defined vehicle have emerged to signify that so much of the car's character is determined by code rather than mechanics. How does that translate into design and driving experience? Traditional cars rely on mechanical linkages, a steering shaft, hydraulic lines for brakes, cables for throttles. In contrast, many new EVs use electronic systems to control acceleration, braking, and even steering, known as drive-by-wire, or specifically steer-by-wire for the steering system. In a steer-by-wire setup, turning the steering wheel sends an electronic signal to a motor at the wheels rather than physically turning a shaft. This might sound like a small technical tweak, but its impact on design is huge. Without a steering column that must angle down to the front axle, interior layouts become far more flexible. Designers can slim down the dashboard, since they don't have to accommodate a big steering shaft mechanism behind it. They can even design steering yokes or rectangles instead of traditional wheels, knowing the software can adjust the steering ratio dynamically, as seen in some cutting-edge EVs, like the Lexus RZ, which offers a steer-by-wire yoke. In the future, steer-by-wire could allow a steering controller that retracts completely when not needed. Imagine an autonomous mode where the car's wheel folds away to give you more space. This technology also filters out vibrations and can adjust steering feel via software, meaning the car's handling character can be tuned to be sporty or relaxed at the push of a button. The absence of mechanical pedals and linkages, with brake-by-wire and electronic throttle, similarly frees up space and allows new pedal arrangements, or even the possibility of moving controls aside when using autonomous driving.